Hello students, welcome to another session on kinematics. Till now, we've seen what is displacement and what is distance for one-dimensional motion. Let's move on to the next concept, which is velocity. Remember, we are looking at one-dimensional motion for now. Let's take an example where an object moves from position x equal to 0 to x equal to 1 centimeters, and then 2, 3, 4. Now there is this object starting from this and going along the east direction. There is another object starting the same kind of motion, starting from this, going along the same path, but there is a subtle difference between object 1 and 2. The difference is this. To reach point 4 or to reach x equal to 4, object 1 takes 4 seconds. So the time taken is 4 seconds. Whereas the second object takes 10 seconds to reach point 4. Are these two motions identical? Are they same? Turns out they're not the same. And the difference is how fast one is moving. Now, if you compare these two kinds of motion, we will also have to talk about how fast or slow is the object moving. Now, when we ask this question, we have a new physical quantity introduced, which is speed. Velocity is somewhat related to speed, and we are going to look at the differences between velocity and speed now. Speed measures how fast an object is moving. This is a scalar quantity, just like distance, and it is defined as the distance covered per unit time. So let's say an object starts from A and reaches B by taking a path like this. The length of this path is, let's say, 12 meters. However, the shortest distance between A and B, the shortest distance between A and B is the length of this line, and let's call this as 8 meters. Okay. The shortest distance is the magnitude of displacement, remember from last lecture. Okay. So distance is this, displacement is this. And speed is defined as the distance covered upon the time taken. Let's say for this entire journey, the object has taken time t equal to 10 seconds. So speed in this case is going to be defined as speed is equal to distance upon time. Now, let's recap what was the distance. The distance was 12 meters. 12 meters upon time was 10 seconds. So 1.2 unit would be meter per second. This is how you define speed. Velocity, on the other hand, is a vector quantity, and it is related to displacement, not distance. Velocity is defined as, since it is a vector quantity, it's defined as displacement by time. Velocity is the rate of change of displacement. Remember, that's the difference between velocity and speed. Speed is the rate of change of distance, whereas velocity is the rate of change of displacement. So in this case, in the same example, we understand that displacement is given by 8 meters. Of course, since displacement is a vector quantity, you also need to include the direction. So velocity in this case, which is also a vector, would be displacement upon time taken. Displacement is 8 I cap upon time is 10 seconds. So 0.8 meter per second, and I cap tells you in which direction is the velocity. So this is the complete information about velocity. So we saw for the same motion, speed came out to be 1.2 meter per second, whereas velocity came out to be 0.8 meter per second. The magnitude of velocity at least came out to be this much. Now, the relation between speed and velocity is pretty unique for one-dimensional motion though. Motion in a straight line. If an object is moving in one direction only and is not changing direction, it's not going back, it's just continuously moving in one direction. So this object keeps on moving towards the east. In such a case, the distance would be equal to the magnitude of displacement. Always. Which tells you that the rate of change of distance would be equal to the rate of change of displacement. How did we define these quantities? This was speed and this is magnitude of velocity. So remember this very important relation that speed is equal to the magnitude of velocity for what kind of motion? For 1D motion happening in one direction. This is valid for one-dimensional motion with no change in direction of motion through the entire journey. So this is a subtle difference and relation between speed and velocity. For one-dimensional motion happening in one direction only. Okay, so it's not turning back. It's not going, it's if it's moving towards the east, it keeps on moving towards the east. Only for such a case, you can say that speed is equal to the magnitude of velocity. So do not confuse when we use this interchangeably. Yeah. However, if the object is turning back, so let's say an object started from A, went to B, and then turned back, went from here to here, and then turned back and came to C. For such a case, what do you think? Will the magnitude of displacement be same as the distance? No. So let's take some numbers and then you can tell me what is the distance and displacement in this case. Yeah. This length is 20 meters and this length is 10 meters. So in this case, the distance would be 20 plus 10, that is 30 meters. And the displacement would be plus 20 minus 10, which is 10 meters, the magnitude of displacement. Okay, if you want to write displacement along with its direction, then you write 10 meters in the I cap direction. Okay, so this is how you represent the displacement. So you can see this is also 1D motion, but here the object is switching the direction. Here the object is changing the direction. Initially it was moving towards the east, then it started moving towards the west. For such a case, for such a motion, speed is not the same as velocity because displacement is not the same as distance. So we can say for this case, speed is not the same as magnitude of velocity. I hope the relation and the difference between speed and velocity is clear. Let's now move on to understanding the different types of velocities that we have. Velocity is characterized into instantaneous and average. So let's look at that. What is average velocity and what is instantaneous velocity?